Good morning, class. Today in Marvelous Mathematics, we're going to learn about prime factorization. Before we start learning though, let's go through the definitions of prime and factor, words that we previously know, to make sure we understand what prime factorization is going to be. So let's start with the definition of prime. Prime is a number that can only, remember class, it can only be divided by itself and 1. So an example of a prime number would be 2. We know 2 is a prime number because we know 2 can only be divided by itself or 1. 4 would not be a prime number because it's divided by 2, or it's divided by 4, or it's divided by 1. The next word we're going to go through is factor, which is going to be the root word of factorization. Now we know a factor is a piece of a multiplication sentence. So for example, let's say we have 2 times 2 equals 4. The factors in this would be the 2's, because they are what are being multiplied together to get the product of the sentence. So with defining both of these words, we can create an overall definition for our word prime factorization to understand that today we are going to be working with factors that are prime numbers. Now to begin this lesson, we're going to need 2 things, a piece of paper or anything you want to write on, as well as a writing utensil. To begin our problems today, I'm going to teach you a method that is called using a factor tree. There are 2 things you need to keep in mind when it comes to using a factor tree. And these 2 things will help you every single time you work with it. The first thing is you need to ask yourself, is this number a prime number? And the second thing is if the answer to that question is no, then you need to find its factors. If the answer is yes, then we're going to circle the problem. So let's just start to an example, that way it's easier to explain. So our first example is going to be the number 6. So we're going to write 6 up at the top. Now look at the number 6. Is 6 a prime number? No, it's not a prime. We know it's not a prime number because we can look at its factors. Its factors are 3 times 2 or 6 times 1. So we've answered our first question, is it a prime? Our second question is look at its factors. So we've looked at our factors. At this point, you can pick whichever set of factors you wish. I'm going to start with 3 times 2, and then we'll come back to the 6 times 1. So we're going to make branches to our tree for the 3 and for the 2. Now we start our steps over again. Are these prime numbers? The 3. Is 3 a prime number? Yes, 3 is a prime number because 3 can only be divided by itself, or 1. So we're going to circle the 3. Now 2. Is 2 a prime number? Yes, 2 is a prime number because we know it can only be divided by itself, or 1. So we circle the 2. So the prime factors of 6 are 3 and 2. So that can be written 3 times 2 equals 6. Now let's go into this problem and use the factors of 6 and 1. So we have our beginning number 6. Now we're going to take our factors and we're going to ask ourselves, is this a prime number? No, it's not a prime number. So break it into its factors, 6 and 1. Now we ask ourselves, is 6 a prime number? No, 6 is not a prime number. To keep from getting stuck in repetition, we're going to use the factors 3 and 2 now. Because we've already looked at the 6 and 1, and we know that we are going to always have a non-prime number over here. So we're going to divide out to a 3 and a 2. Is 3 a prime number? Yes. So we're going to circle it. Is 2 a prime number? Yes. So we will circle it. Now we have a 1. We should already know by prior knowledge that 1 is not a prime number. In this case, we are just going to cross out 1s when we encounter them in a factor tree. So again, we have the answer of 3 times 2 equals 6. Now let's try another example. Let's do the example of the number 18. So we'll start with the top of our tree, which is going to be 18. What are the factors of 18? If you need to list them off to the side like we did here, it can be very helpful. So I'm going to do that. I know some factors of 18 are 9 and 2, so I'm knowing right now it's not a prime number. 18 times 1, 6 times 3. These are the ones I can think of off the top of my head. So I'm just going to go with one of them because I know that all these factors will end up working. So I'm going to start with 9 and 2. 18, its factors are 9, and 2. Is 9 a prime number? No, 9 is not a prime number. So what are its factors? 3 and 3. Those are two numbers I just came up with that I know are factors of 9. Now, is 3 a prime number? Yes, 3 is a prime number. So we also know this 3 is a prime number. Now what about 2? Is it a prime number? Yes, it is. So we will circle it. So our answer for this one of the prime factorization of 18 would be 3 times 3 times 2 equals 18. Now on this, what we can examine here is that 3 times 3 times 2 equals 18. We have two 3's right here. Since we understand exponents, we can do 3 to the power of 2 times 2 equals 18. These two equations are equal to each other, and either are acceptable when being an answer. If you want to simplify it into exponents, that's okay. But it's also okay to leave it written out like this. Now I'm going to move back over here, and we're going to work on a problem together. I'm going to write the problem on the board. I want you to pause the video after I finish writing it, and then I want you to attempt the problem on your own. Then unpause the video, and I will continue to go on the problem, check your work against mine. So our example is going to be 144. Please pause the video and go on and try to solve this problem on your own. Now 44's factors, two that I'm just going to come up with that I know because I know my facts, are going to be 12 times 12. Is 12 a prime number? No, 12 is not a prime number. But I do know that 4 times 3 is 12. So I found my factors. Is 4 a prime number? No, it's not. But I know 2 times 2 are the factors of 4. Is 2 a prime number? Yes. Is 2 a prime number? Yes. And is 3 a prime number? Yes, 3 is a prime number. We're going to do the same thing for this 12. I'm going to use a different set of factors this time to get a little bit different of a tree. So let's use 6 times 2. Is 6 a prime number? No. 6 factors are 3 and 2. Is 3 a prime number? Yes, it is, so let's circle it. Is 2 a prime number? Yes, it is, so let's circle it. And is 2 a prime number? Yes, it is, so let's circle it. So the prime factorization of 144 would be 2 times 2 times 3 times 3 times 2 times 2 equals 144. And these numbers are all of our numbers that we have circled right here. Now in this case, since the number sentence is so long, it might be easier to put it in exponential form. So let's count up our 2's. 1, 2, 3, 4. I have 4 2's. So 2 to the power of 4. Now I have 1, 2, 2 3's. So it's multiplied by 3 to the power of 2, which will equal 144. If you're struggling with this concept still, you can go to an online website that is on mathplayground.com/factor trees, and you can practice more factor trees on your own. It's a simulation that will bring up the main number, and you can go through and you will type in the factors, and it will tell you if you're right or wrong, and you will continue to do so all the way down until you get to your prime. Thank you for watching, and I hope you enjoyed Marvelous Math today learning about prime factorization.